All right. So lately I've been thinking a lot about, the potential for AI to really tackle some serious math problems.
Yeah.
We're talking like college level stuff.
Yeah, the kind that makes a lot of people sweat, right?
Exactly, like calculus and things like that.
Absolutely.
And to really test that, we're diving into some brand new research based on this thing called UMath. Have you heard of
It
this?
have, yeah. It's a
Yeah.
benchmark, right? With a whole bunch of university level math problems,
Yeah.
like 1,100 of them pulled straight from courses at top US universities.
That's right. Pretty intense.
Yeah, it's pretty impressive.
So UMath, it's kind of a big deal because it goes way beyond like the high school level problems we've seen AI tackle before, right?
Right, exactly. And it's not just, simple arithmetic or algebra.
Right.
It covers 6 core subjects, from pre-calculus all the way to multivariable calculus. And here's the really interesting part.
Okay.
20% of the problems include visuals,
Right.
like graphs and diagrams.
So it's not just about like crunching numbers.
Yeah.
It's about being able to connect visual elements to abstract concepts, which sounds really tough.
Yeah, it adds a whole other layer of complexity to the problem-solving process, right?
It does. So it really gets to
Yeah.
whether these models can handle that kind of conceptual understanding that you need for higher level math.
Exactly. Because it's one thing to, manipulate symbols and equations,
Right.
but it's another thing entirely to be able to understand what those symbols and equations represent.
Yeah, to be able to like look at a graph and know what it means in a mathematical sense.
Precisely.
So, big question.
Yeah.
Are our AI buddies passing with flying colors? What's the verdict?
Well, not quite. Turns out even the most advanced LLMs, they're still hitting a wall when it comes to this kind of complex reasoning.
Oh, really?
Yeah, especially when visuals are involved. And what's interesting is that the size of the model isn't the only factor here.
So it's not just about brute computing power.
Not necessarily, no. The researchers found that specialized models, even smaller ones, can sometimes hold their own against those big, massive models.
That's interesting.
Yeah, like there's this one model, Quinn 2.5 Math 7B,
Okay.
and it performs surprisingly well, even though it's not, one of the biggest models out there.
So that suggests that the type of training, not just the scale,
Right.
is really important.
Exactly. You wouldn't expect like a general purpose AI to be as good at calculus as one that's been specifically trained on math problems.
Yeah, that makes sense. But I'm curious, how do the researchers even come up with these UMath problems?
Oh, that's a fascinating part of this.
Yeah.
They didn't just like pull them out of a textbook or anything.
Right.
They actually used other LLMs to help them select the problems.
Oh, wow.
Yeah. So they started by filtering out the easy problems,
Okay.
and then they used a bunch of different LLMs to pick out the most challenging ones to make sure that no single model had an unfair advantage.
Whoa, that's meta. So they basically used AI to design a test for other AI.
Exactly.
That's awesome.
Yeah, and it's like the AI helped create its own ultimate math challenge.
That's so cool. So they used what, like different models to do that?
Yeah, they mentioned using models like LMA 3.18b and Qwen 2.7b.
Okay, and that was all just for creating the test.
Yeah, just for that selection process.
Wow. Okay, so I'm a very visual learner. Can
Yeah.
you walk me through like an example of a UMath problem that really tripped these models up?
Sure. There's this good example from the differential calculus section.
Okay.
It involves finding the velocity and acceleration of a particle based on its position function.
Uh-huh.
And then you have to figure out like when is it speeding up or slowing down.
Oh, yeah.
And you have to work with derivatives, interpret results, take into account things like, non-negative time.
Yeah, I remember that stuff making my head spin back in college.
Right.
Like that was not easy.
No, not
Or
enough.
especially when you have to like visualize it and stuff.
Yeah. Exactly. And that's where a lot of the LLMs really struggled.
So it highlights just how complex these seemingly simple problems can become when you're dealing with like higher level math.
Right, because it's not just about, plugging in numbers and getting an answer. It's about understanding the underlying concepts and being able to apply them in a flexible way.
Yeah, it's like it's not just about memorizing formulas, it's about like actually understanding the concepts behind them.
Exactly.
Okay. So we've established that solving university level math is still pretty tough for AI. But there's another layer to this research, right?
Right.
Tell me about math, this meta UMath thing.
Okay, so this is where things get really interesting, I think.
Okay.
So math is designed to assess something even trickier. The ability of LLMs to judge whether other LLMs got the UMath answers right or wrong.
Whoa, hold on. So it's like AI grading AI homework.
Exactly.
That's
It's
amazing.
a whole other level of meta,
It
right?
is. It is. So, like, how did they do? Were they handing out A's or failing grades left and right?
Well, it turns out judging is just as hard as solving. Even the best model only achieved an F1 score of 80.7% on math,
Oh, wow.
which is like a B minus at best.
That's not great.
No, not really. And what's even more interesting is that different types of models displayed different biases in how they graded.
Okay, now I'm really intrigued. What kind of biases are we talking about here?
So, for instance, the models from companies like Google, they tend to be more cautious in their judgments.
Okay.
Like a really strict teacher who's not going to give you the benefit of the doubt.
Right.
Whereas the open weight models, like those in the Quinn family, are more willing to follow the logic of a solution,
Uh-huh.
even if there's a chance it might be a little bit off.
So it's like having a strict grader
Right.
versus one who's more lenient,
Right?
but maybe a bit more prone to like overlooking some errors.
Exactly.
But isn't that a problem if we're trying to figure out how good these models really are at math?
Absolutely. Because it means relying on a single LLM to judge the answers could give us a skewed picture.
Right.
It's like having just one person grade all the SAT exams. You'd want to have multiple perspectives.
To make sure everything is fair and accurate.
Exactly.
Yeah, that makes sense. Anything else about math that really jumped out at you?
Yeah, one thing that really stood out was how the way you ask the LLM judge matters a lot.
Oh, interesting.
So, manually crafted prompts where you guide the AI through the steps of reasoning tend to outperform automatic prompts.
So even when you're evaluating AI, you have to phrase the question just right.
Right. Just like with a person, you might get a different answer depending on how you word the question.
Yeah. It's like it highlights the importance of like carefully thinking about how we design these evaluation methods.
Exactly. Because the way we evaluate these models can have a huge impact on our conclusions about their capabilities.
And that leads us to another fascinating aspect of math. This is blowing my mind, by the way.
Oh, yeah, me too.
Like, this is really meta.
It is.
Okay, so what else did they discover?
Well, they found that being a great math problem solver doesn't automatically make you a great judge.
Wait, really? Now that is surprising.
Yeah, there seems to be a bit of a trade-off between those skills.
Tell me more about that.
Yeah, it's almost counterintuitive, isn't it?
It is. You'd think if an AI can solve these crazy calculus problems,
Right.
it could definitely spot errors in someone else's work.
Yeah.
But it sounds like that's not always the case.
Not necessarily, no. So remember those Quen models we talked about? The ones that are so thorough and show every single step?
Oh.
Well, that tendency actually seems to make them less effective as judges.
Oh, really?
Yeah.
So they get bogged down in the details.
Kinda, yeah. It's like they're so focused on checking every single step
Right.
that they miss the bigger picture. Or they get distracted by, a minor error and miss a larger flaw in the logic.
So it's almost like when you're trying to debug code
Right.
and you get so focused on one line,
Yeah.
you miss that there's a bigger problem somewhere else.
Exactly. And while that thoroughness might lead to accurate judgments in some cases, it also means they might miss those more subtle errors in reasoning.
Interesting. So whereas those company-backed models, the ones that were more efficient,
Right.
they were more likely to just look at the final answer and say, yep, that's right, or nope, that's wrong.
Exactly. They seemed less concerned with all the steps leading to the solution
Okay.
and more focused on whether the end result was correct.
So it's kind of like they skimmed the essay and just checked if the conclusion was right without really reading the whole thing.
Right. A perfect analogy. So each approach has its own strengths and weaknesses.
Right. It's like that classic trade-off between thoroughness and efficiency.
Exactly. And it makes this whole problem of evaluating LLMs even more complex. Right?
It does. Because it's not enough to just look at the score.
Mm-hmm.
We need to understand how they arrived at that judgment.
Precisely. And that's where using multiple LLMs as judges gets really interesting.
Oh, yeah, we were talking about that before.
Right. Instead of relying on a single LLM to be the ultimate judge, what if we combine the judgments of several different models?
Kind of like a panel of experts, each with their own strengths and weaknesses.
Exactly.
That makes a lot of sense, actually. Did the researchers try that out at all?
They did, and what they found was pretty amazing. They found that no two models agreed on the correctness of a solution more than 80% of the time.
Wow, that's really low.
Right. And this wasn't just true for models from different families. Even models trained on very similar data disagreed quite a bit.
So even AIs with similar backgrounds can have drastically different opinions on what constitutes a correct math solution.
It seems that way, yeah.
Yeah.
And it really highlights the need for more diverse and rigorous evaluation methods, right?
Absolutely, because we can't just assume that one LLM is going to be as good a judge as another, even if their performance on other tasks seems similar.
Exactly.
This is really making me rethink how we evaluate AI in general.
It is fascinating, isn't it?
It is, because we're so used to thinking about what AI can do. But this research really forces us to think about how they're doing it, and whether they're doing it in a way that aligns with our own understanding of these concepts.
It's a really important distinction because as these models become more sophisticated and integrated into our lives, we need to be able to trust their judgments.
Absolutely. Speaking of integration, I'm really curious about that idea of giving LLMs access to external tools to help them with math.
Oh, yeah, that's a really promising area of
It
research.
sounds like it could be a game changer.
It could be because it could help overcome some of those limitations we've been talking about, especially with visual elements or, really complex calculations.
Right. So instead of expecting them to hold all that information in their brains, we could give them access to Wolfram Alpha or something like that.
Exactly.
So they could basically outsource the heavy lifting and focus on the reasoning.
Precisely. It's like giving them a powerful research library or a team of specialized assistants.
Okay, that makes a lot of sense. And it would be fascinating to see how that affects their performance on benchmarks like UMath.
Oh, absolutely. I think it has the potential to significantly enhance their abilities.
Yeah, and it makes you wonder, how far can we push this? If we can combine the reasoning power of LLMs with the computational power of these external tools, what might be possible?
It's a really exciting thought. And it leads to another question. What impact could this have on how we learn and teach math?
Right. Are we going to see AI tutors become the norm?
Maybe. And it makes you wonder, will the types of mathematical skills that are valued change as a result?
These are all questions that are worth exploring.
Absolutely.
And speaking of exploring, I just wanted to mention to our listeners that the researchers behind UMath and Math have made all their data and findings publicly available.
Oh, that's great.
So anyone who's curious can dive in and see for themselves.
I definitely encourage everyone to take a look. It's fascinating stuff.
It is. And who knows, maybe some of our listeners out there will be inspired to contribute to this exciting field of research.
I wouldn't be surprised. It's a field that's really ripe with possibilities.
It is. Okay, so before we wrap things up, I want to shift gears one last time and think about some of the bigger picture implications of all this.
Okay.
We've talked about AI's capabilities and limitations.
Right.
But what about the ethical considerations? What do we need to be mindful of as this technology continues to evolve?
Yeah, that's such an important question. Because as AI systems become more sophisticated and we integrate them more into our lives,
Yeah.
we need to make sure that they're being developed and used responsibly.
It's not just about what they can do, it's about what they should do.
Exactly.
We have a responsibility to guide the development of this technology in a way that benefits humanity as a whole.
Absolutely. And that means thinking about potential biases, ensuring transparency and accountability, and constantly evaluating the impact of this technology on society.
Yeah, it's a conversation that we all need to be having, and one that we can't afford to ignore.
I agree.
The future of AI is in our hands, and we need to shape it wisely.
Well said.
This deep dive has been incredibly insightful.
Yeah,
I've covered a lot of ground,
we have.
from those technical details of UMath and OIMath to these broader implications for AI research, education, ethics.
It's all connected.
It is, but one thing is clear. This is just the beginning.
The beginning of a much larger journey.
Exactly. And we encourage all our listeners to keep exploring this fascinating world and stay curious. And that's a wrap for this episode of The Deep Dive.
Thanks for having me. It was great to dive into this with you.
Yeah, this was fun. Until next time, keep learning and keep diving deeper.
All right, so we're back, and my brain is honestly buzzing after that last segment.
Same here.
I mean, it's incredible to think about AI tackling college-level math, but it also raises so many questions.
Well, absolutely.
Like, are we actually on the verge of creating machines that can think like real mathematicians? That's the big question, isn't it?
It is.
I mean, we've seen these LLMs do some pretty amazing things,
Right.
but, is it really thinking? Or is it just really, really good pattern recognition?
That's what I keep coming back to. I get how an LLM can be trained on tons of data and learn to solve equations, even really complex ones.
Right.
But does it actually understand the concepts behind those equations?
That's the core issue, right? Because even the most advanced LLMs, at their heart, they're still basically pattern recognition machines.
Right.
They're incredibly good at finding those patterns in data and then exploiting them.
Right.
But whether that's actually the same as, true mathematical understanding, like what a human mathematician has,
Right.
that's still very much up for debate.
So it's like maybe they're just really sophisticated calculators
Yeah.
that can, follow a set of rules to get to the right answer, but they don't really get the why behind those rules.
Yeah, I think that's a good analogy. Like they can crank through the steps.
Right. But do they have that deeper conceptual grasp? We don't know.
And I think it's easy to get swept up in all the excitement about AI.
Oh, for sure.
And start thinking of them as almost human,
Right.
Especially when we see them do these amazing things.
Yeah, but I think it's crucial to remember that they're still tools.
Right.
And like any tool, they have their strengths and their limitations.
And it's up to us, the humans, to use those tools responsibly.
Absolutely. The future of AI it's not predetermined.
Yeah.
It's being shaped right now by researchers, by developers, by policymakers.
By everyday people using these tools.
Exactly. And it's up to all of us to make sure that it's a future that benefits everyone.
That's a great point.
Yeah.
This whole deep dive has really been a roller coaster of emotions for me.
Yeah.
Like, I'm in awe of what AI can do, but I'm also a little bit apprehensive about what it all means.
I think that's a healthy perspective.
Yeah.
Because it's important to be both excited about the possibilities
Right.
and aware of the potential risks. Exactly. So to all our listeners out there, I just want to say, keep exploring this world. Keep learning, keep questioning, and definitely stay curious. And that's a wrap for this episode of The Deep Dive.
Thanks for having me. It was a great discussion.
Yeah, this was awesome. Until next time, folks, keep diving deeper.